Good morning, everyone. My name is Sai Kiran. Today, I am going to present our project titled Nmk Certification Portal. This project was built to provide an online examination system. Let's walk through a requirement first. Our project is Technology Certification Portal. Our idea is we should provide a platform to test the candidate's knowledge on a technology. Requirements are valid users should be able to log in to the portal are invalid if user shouldn't. Each candidate should get a different set of questions with equal percentage of easy, medium, and hard for all the candidates. Display the candidate results after the exam completed or timed out. Candidate should be able to resume the exam where it stopped in case of network errors. It's a format. Our contents are 20,000 users should be able to write the exam at one go without any performance issue. You have to reflect a brand name as NMK, like it's like NMK certification portal. Uh, Now walk through the flow of the entire system. Our goal is to allow the users to take online exam at same time and generate random questions sets, save the progress, and show the results. Now, first we have user login credentials. Candidates open the portal, then candidates enters username and password. Password is checked in database. If it's valid, the data icon is created and written. If invalid, request is blocked. Then we have to start exam. Users click the start exam. Backend selects the random question set but ensures 33% easy, 33% medium, and 33% hard. The selected questions are saved in candidate's exam record in a database. Candidate take the exam. Each question is shown the one by one in front end. Timer runs. It's like we fix like 15 minutes or 30 minutes. After answering a question, saved in a database. The next network failure or Windows close. Answer and current questions numbers are always saved. When candidates returns, backend checks. If exam not completed, doubts and saved questions index. Resume from where they stopped. Timer also contains remaining time set from backend. Then submit exam. Candidates submit exam manually or when time expires. Backend calculates and correct answers, wrong answers, and total score. Results stored in database. Then displays results. Marks pass or fail shown in front end. Admin can also view results. Moving to next slide. Here is the technical architecture and project what we are using. We use like fast APIs, UVCon standard, SQL Alchemy, Pydantic, Parsley, Bgrip, Python, Python JAWS for cryptography, Python multiple path, Streamlit, request. We have backend. In backend, we have fast API. It handles the authentication, question distribution, exam logic, timer logic, resume exam fallback, storing results. In front end, it's a Streamlit handles the login page, start exam screen, timer display, question navigation, submit button, and page result. Now moving to next slide. In backend, we have a files like main.py, mo main.py, model.py, schemas, authentication, exam, database. Now I will explain each file, what it contains. Main.py, in main file, we have like a start. It's used to start fast API server, includes all routers creates to database connection. In models, define all the database tables. It shows like users, question, candidate exam, and candidate answer. In schemas, it defines like input or output of data models using Pydantic models. It contains like a login request, exam start response, question schema, and results. In authentication, we have like login, creating or verifying the JWT tokens, password hashing. In exam file, we have start exam, getting new question, save answers, and resume exam, submit answers, and calculate the score. In database file, we have database connections and session management. Now moving to next front end file, we have like login page, exam UI, and timer, submit button, and result view. And database, it stores users, questions, candidate exam, who took what exam, and answers and score progress. Now let walk through the every file of codes one by one. I I want to clearly explain. First, we will start with a main file. Uh, from fast from fast API, import fast API. Fast API here. Fast API means the main framework we use it to build backend APIs. Here, depend shows that user for dependency injection. Example, like checking login token. As we know, HTTP exception means you use it to send the error message. Here, body, it shows that use it to accept the raw body data like JSON format. Next, from fast API middleware dot course import. Course middleware means mm, allows our front end Streamlit and backend fast APIs to communicate even if they run on the different ports. It shows like I will show at the last example like 8501 and 8000. Then moving to next line, SQL Alchemy. SQL Alchemy import session means session is used to talk to the database. Then flag modified is used tells a SQL Alchemy that a JSON column like answers has changed and must be saved. Then moving to next line. From insert questions, import insert question means a function that adds a default questions to the database. Moving to next line. From .db import base engine means base class for all the database models. Here engine indicates that database connection engine. Next, moving to next line. Import from import models. Here importing other modules in our project. Mhm. Here models show that database tables, schemas, schemas is for input and output validation. Auth is for login and JW token password hashing. Exam shows that exam logic, selected questions and compute the score. And date and time, import date and time. It stores the exam and time. After imports, we are creating the app. We are titled as a Nmk certification portal, fast API application. Then we are adding a core settings, allows requests from all domains. It's requires because front-end Streamlit and backend run separately. Here, star means allows everything safe for development. Then we are creating a database tables based on metadata. Create all bind engines. Bind equal to engine. Automatically creates all database tables defined in models.py. So next we are going to user registration. Here we have register means register. It is a registers endpoint. Accepts user details. Accepts user details using a schemas for users registering. Injects database session using auth.getDB. Then moving to next line. Uh, Here this line checks that checking that email is already exist. If yes, if yes, throws the error. Then moving to hash equal to auth dot get password and hash payload password means password is hashed from security. Moving to next line, it shows that creates a new user object in admin. In admin false, it's a normal user. Moving to next line, it's used for saves users to database, refresh and fetches updated data. Then it's a return message, return it. Then this line shows that returns success. It shows to return successful message. So next here is the login page. Here we have like login endpoint takes a raw file like JSON payload, user database system, database session. Uh, then extract email and password from a body. Then moving to next line, verifying login credentials. If wrong, throw the error. It then it's token equal to auth create means this line that creates a JW2 access token stores email inside the token. Then return means send tokens back to front end. Then token is used for all future requests. So next, moving to adding questions. This line shows that only admins can add the questions. Validates user using JWT tokens. Then it blocks the non-admin users. Then this line shows that ensures difficulty is valid. Then next, here question means creating question object. Text is shows that question text, choices of the question, answer index table, and difficulty level. Here we are saving the questions to database. Then returns successful. So next we are starting the exam. It creates a new exam session for each candidate who are who are writing the exam. Here Q count 9 means total number of questions. Then duration seconds. 1800 means as we know it's a 30 minutes. Then moving to next line, calls a candidate exam means it calls a function that selects a random question, creates a exam record, save question IDs. Then next it's like returning the this sends exam details to the front end. So next uh, load a default questions on a startup. This runs automatically when server starts. Here inserting questions loads a default question is not already presented. Next here we are showing that getting to get a exam details, which a complete exam including questions. Okay, ensure exam belongs to logged in session. Uh, if not a candidate exam, then it raises it error token like HTTP exception and 404 exam not found. Here we have for saying answers, selecting questions. We all do. Then returns that question ID, questions, time allowed in seconds, time allowed, and status. Then next, it's used to save the answer. Save each answer immediately after we choosing the answer. Use it for resume on network failure. Mm. Here used to saving answer. Exam ID is taken in a string. Payload schemas. Here used as a schema answer. Current user models. Then DB session. Depends on auth to gateway file. Then candidate exam details. If candidate exam, if not a candidate, it raises the error. It shows a candidate exam status is in progress. Status is status code is 400. It shows the error. Then details is exam is not in progress. Then we are creating a new dictionary properly to save the answers. Mm. Loading existing answers and stores the new answer. Then here flag modified candidate exam answer means it tells us the SQL alchemy that JSON file fill changed. Then moving here next we have to save the last time elapsed time and marks exam completed and then calculate to use to calculate the score. To compute the fine here steps are used to compute the fine after end of the end exam compute the score of the candidate. Then it is used this line is used to network disconnected and loads a previous answers and time. Then we here start first we are it is used to resume the exam. Exam ID is a string and taken. Then here here it's used a auto timeout logic. When you start the exam, it counts as time in a minutes. After the timed out, it shows. Then it's returns a score and detailed questions and detailed question wise result. Then it checks the correct answers and validate our score. That's all about this file. Now moving to auth file. It's used for authentication. Here, first we are importing from passlib context import crypt concept means this imports a tool used to hash a password securely. We never store a plain passwords in a crypt context. Helps us to hash and verify the password. Then from those we are importing JWT error and JWT. Then JWT is used to create a read JWT tokens, JSON web tokens. These tokens are like a digital ID card gives to a user when they are logged in. JWT error helps us to catch a error if the token is invalid or expired. Used to handle current time, daytime and time delta as we know. Used to handle current time and expiry duration from the JWT tokens. Now moving to next line, we are importing like from fast API, we are importing depends. As you know, depends helps a fast API automatically injects dependencies like database session and token. Here, HTTP exception is used to raise errors like invalid login. Then status provides standard HTTP states of codes like 401 authorized. Then first, this fast API built to authentication and system. Accept a token from users for protected the routes. User to interacting with the database sessions. The importing session. Here the session local means helps to create a connection to the database. Then here importing the models. Contains our database tables like user table. Then moving to next line. Here we are. It's for settings like a security key used to sign in with a JWT tokens. If someone gets this key, they can create a fake tokens. So it must be keep a secret. The algorithm is used to generate JWT token signature as we HS256 is commonly used and secure. Access token expire minutes 16 to 24 minutes. It's a 24 hours format. It expires in a 1 day. Then moving to next line. Uh, from this line, we are configuring the password hashing. Argon 2 is used to which which is the one most secure in the algorithms today. Tells the fast API that's the authentication. We accept a bearer tokens. The token will be generated from the login endpoint. So next database connection dependency. Uh, get DB creates a database connection. Yield means gives this data gives this database connection to the API function that needs. Then it closes. After the function finish, DB closes the connection. This prevent database overload. Next, password verification and hashing. Uh, here, plain shows that password entered by user. Hashed means password stored in database. Returns true if they both matches. Moving to next line. Uh, converts a plain password into a secure hashed version before saving into the database. Next, we are creating JWT tokens. This line shows that data contains token into like a user email and make a copy. Then we are making a copy, so we didn't modify the original. Mm. Then next line, calculate expire time. If no custom expire pass, users use a default in 24 hours. Then moving to next line, add expiry time into the token payload. Create this final JWT tokens, user for security keys and return the tokens to users after the login. Moving to next line. Here helps us to use user from database. Look for user in the database using email and returns the user object if it found. Next, it's user for authentication used during a login. Mm. This line shows that check a email exists in database. If user not found and returns none, invalid user. If password is wrong and returns none. If both correct, returns user. This function answers the question in the login if login is valid. Then next we are get current logged in users from a token. This line shows that get a token from request header and sorry and get database connection. Then this line shows that Recreate an error message in case token is invalid or expired. Then decode the code, decodes the token using secret key. If token is fake or expired, it shows the error. Then this line shows that JWT tokens store user email inside subject. If it's missing, the token is invalid. Then if decode say fails, raises 401 authorized. Then it looks up the user database using email inside. And if user doesn't exist, invalid token shows. If valid, returns a user object. That's all about this file. Hmm. Now moving to database file. It's a data, as we know, it's a database file. First, we are importing create engine. Create, we are importing create engine from the SQL Alchemy. An engine is the main connection point between our Python program and our database. Think of it like a bridge that connects a fast API and PostgreSQL. Then we are importing a session maker. Creates a database session used for reading, writing data. Then declarative base shows that user to create a base class from our database models and tables. Every model we create a users, questions, exam, etc. will inherit from this base. Then this line defines the connection string to the PostgreSQL. It's PostgreSQL, it shows that database type. It is a database type. Then Postgre is a username. Then 1234 is a password. And localhost is a database running on our own computer. Here 5432 indicates that PostgreSQL default port. Its Nmk portal shows the name of the database. This URL tells a SQL Alchemy where our database lives. Then here we create a database engine using the connection URL above. This establishes the actual connection to the PostgreSQL. Without this engine, our backend can't talk to the database. Moving to next line. Here session local season maker. It's auto commit shows that it's a false. It's so equal to false. It shows that changes are not saved automatically. uh, we auto refresh, auto flush if equal to false means is actually like SQL Alchemy won't push the changes automatically. Bind equal to engines. This session connects to the our database engine. If this used everywhere in backend, like for authentication, exam, and CRUD operations. Finally, for the next 10th line. mm, is this is the base is a parent class for all database tables. Every model like users, questions, exam will inherit from this. Will inherit from this. SQL Alchemy is a base to create a tables internally. Then moving to next line, next file models. We are importing Python built-in NM model. This is used to define predefined constant values like easy, medium, and hard questions difficulty. This imports next we are importing UID. This imports UID module means generates unique IDs like uh, with a mix of numbers, symbols, and letters like 12 AB, 44 CC. Nine is for like we can think like unique IDs, not hacked by some other ones. These are used instead of simple numbers to avoid the conflicts. Then import SQL alchemy column types. Column shows the types. These all tell the database when type of data each field that stores. Then string stores a text, integer is a number, date and time is a timestamps, boolean true or false, enum is for predefined options, and JSON file. Moving to next line, we are importing the function. Function allows us to run SQL functions like now and current time. Importing the base class. .db, we are importing a base class. All models must inherit from a base. So SQL Alchemy can create tables. Then it helps us to this function generates unique ID every time it is called. Uh, then here it's returning UID4 means creates a random unique string. All our tables use this function for a primary keys. Then it's a difficulty enum. This defines three fixed difficulty levels: easy, medium, and hard. As well, Alchemy will store this as a strings usage of example. Difficulty is easy, then user model. Then we defining a new table named user. It inherits from a base, so SQL Alchemy knows the database models. Then this line shows that uh, set the table name is a database users. ID columns is a primary key. Users gen ID. So every user has unique IDs. Stores user email. Here unique to means now no two users can have the same email. Then index two, it's a faster loops. Nullable, it's a false. Must not be a empty. Then moving to next line. Store the candidate exam. Then hashed passwords. Stores the encrypted password. It never be a plain text and must not be a empty. Then moving to next line. If it's true, user is admin, then default is a false. Then automatically stores when user is created. Uh, then function stores the current timestamp. Then it shows that question unique ID and stores the question text. Example like what is the Python? Then it shows answer index. This shows the index of correct answer. Example, if the correct answer is Python, it shows choice like Java, Python, C, then the answer index is 1 because indexing starts from a 0. It's a difficulty column. It stores a difficulty level. Must be 1, easy, and medium, hard. Candidate exam model. Models to store every exam attempt. Here table means candidate exam. Then it shows that unique exam attempt IDs. Then ID of the user who is writing this exam. Stores the list of questions given to the candidates. Helps to resume exam. Stores the user answer in dictionary format. Time, it shows that when exam is started. time and if exam ended. Null until the exam finished. Status of the exam is like in progress, completed, and timed out. And it shows that total duration of the time. Then time elapsed shows that track how many seconds are completed, helps to resume exam after the network breakup. Then it scores the column table. Candidate score after the exam submitted. Moving to next slide. Next file, exam. We have to discuss like exam file. Here we are importing secrets. Secrets provides a cryptographical strong random numbers. Is used to generate random seeds. So each candidate gets a different questions. Then lie to random. It's used to like for shuffling questions. Python build a random model. So use it to shuffle selected random questions. Import list. Use it for type hints. List string means the function returns a list of strings. SQL Alchemy is a session object. Allows user query to the database. Import our data models. Importing our data. Here question shows that MCQ questions, candidate exam, exam session details. Difficulty is easy, medium, and hard. Users only if needed to create a database session. User to handling timestamps. Then it is a select questions balanced function. This function selects a questions with a equal distribution, easy, medium, and hard. It defines a function. DB. This line defines a function. DB means database connection. Total unequal to it's a default question values. Then equally split among easy, medium. Uh, then floor is not a divisible. Then this line we divide quotient, we divide, then here we are dividing quotient equally into three difficult categories. Example, n divided by 3, then 3 each. If number don't divide perfectly, remaining will store leftover count. Then moving to next line, distributing remainder and then starts from easy. Distributes leftover questions. Priority order. Easy, medium, hard. If example of 10 questions, 3 each, then remainder is 1. And then add extra to easy. Then this lines for each difficulty, easy, medium, hard. Fetch all questions from database. Extract only their IDs. Stores them in a dictionary called pool. Hmm. Example, in pool, we are using ID1, ID2. In medium, ID3 and ID4. And hard, we have like ID5. Moving to next line. Here, selected will store final question IDs. Then it ensures different candidate gets a result. So we create our own random generates loop through difficulty level. If it's easy, how many, medium, how many, and hard, how many. For each difficulty, here items, all question ID available. If available questions are fewer than need, take all. Else, randomly choose required count using rag simple. Add question, add chosen ID files and selected list. Then rig shuffle. Shuffle finally questions list of so candidates doesn't get order by difficulty. Then it's returns selected. Then it's finally returns a final list of question IDs. Creates a new exam session for the candidate. Mm. Going to next line. Here arguments we use like DB, database, user ID, mm, which user is writing exam, duration, exam duration, queue count. It shows that number of questions. As a default, we given 9. Queue IDs, selected question balanced. DB total queue count gets a balanced list of questions. Then we are creating a new candidate exam object. User ID is owner. Question ID is list of questions given. Here an answer we have initially attempted. Status in progress. Then save the exam to database and commit changes. Refresh to get updated values like a ID. Then return object. Then compute a score. Calculates final score after the exam submission. Take DB session and exam. If not candidate exam, load stored answers. If none, using empty dictionary. Printing debug info. This print statements helps us to understand happen during the scoring. Then computing score, total score, and stores the answers. Loads full questions from the data table. Answers dictionary stores a string. Converts ID to string match. Comparison logic, if the cell is none, then it continues. If user didn't answer, then it skips. If selected, choice index equally correct, answer index after loop, uh, after loop, it scores the present percentage and stores the result candidate exam of the present. Then returns a final score, then return percent. Here a short summary about I want to explain short summary about that exam file. It contains the core exam logic. First, we will select your questions with equal difficulty distribution used to balance selection function. Then we create a candidate exam record and store selected questions, then timer and status. Finally, we compute a score and loads the questions and compare stored answers, which correct ones and calculate the percentage score. This finally ensures fair exams, question randomization, and accurate scoring. Now moving to next file, schemas.py. Here, schema file. This file defines a data models used by data used by fast API. These models helps us to validate input coming from the front end and structure output going to the front end. Uh, we use a Python library that guarantees the data is correct format. Email must look like a email, number must be a number, and list be a list, etc. So importing a models from Pydantic import base model. Base model, it shows that every data schema must inherit from this. It gives a automatic validation. Then email string it's specially typed for a email validation. If email is invalid, Fast API automatically rejects it. Then we are importing from typing, list, dictionary, and optional. Uh, Use it for typing list of strings, dictionary, and optional fields. Then we are registration for input schema. This model is used when a new user registers. Then email, it shows that email must be valid. Then here password section is password is a string. Here name is like it's optional. Optional means user may or may not provide their name. Default value is known as none. Then we have token schema. Here class token. This schema defines that server sends a back after login. Access token. This JWT token string. Then token type is bearer. Stands a name to token using authorization header. Login input schema. Class login here explain where users login must give valid email and must give correct answers. Question input schema. Class The schema is used when admin upload new questions into database. Here text is actually questions text. Here choices we have a list of four choices. Here is the answer index, correct answer index, and difficulty level easy, medium, and hard. Question output schema. This is the set of front end when the student answer the question. Here ID is question ID database, question text, list of options, level of question. Exam create option. ID is exam session. Random question selected in algorithm. Time allowed in seconds. Runtime uses this render function. ID, exam ID, questions, list of question outputs. Time allowed, total allowed time. Time allows, how much time is already stamps in progress. Then here for submission. When user submits a single question answer, this schema is used. Which question student is answered and what option they selected, total time of student already taken. And finally we have to discuss our front end app.py file. Dot py file. It's a front end file. As we know, definition of Streamlit. Streamlit is a Python library that helps us to build a web application using only Python. No need of no HTML, CSS, or JavaScript. We can write a normal Python code and it's using Streamlit shows as web application. Now look into the code. Import Streamlit as st. It imports a Streamlit and gives it a short name as st. All UI session states functionally comes from this. Import requests. This is a popular HTTP client used to call all our backend API. Import time provides time related function like time, time dot sleep, and etc. Used for the timer. Here API this link it's a basic it's a base URL for our backend. All API requests are built from this. It's st.setPageConfigure means Set a streamlit pace of options. Title shows that browser tab and layout. Why to use more horizontal place. Then here we are from these lines we are installation of sessions. Def in session it defines a function, ensure requires a session and variable exists. Here default dictionary of all the default sessions, uh, session keys and their starting values, access token and user email for a authentication, exam ID and questions for current exam. Answer is an empty dictionary that will hold the question IDs and selected index, time remaining and time original track this exam timer in seconds. Status include is none, in progress and completed. Yeah. Submitted. Submitted is like a boolean to avoid the resubmitting. Last saved stores which answer where the successful saved it to backend avoid to duplicate saves. Last time tracker. Tick. It stores a last timestamp when timer was updated, user to decrement every second. Then here for KV, if K is not in ST session state, only set of default is not already present. This preserves value across the reruns. St.state means set of session state, keep a default value. In session calls in session immediately, so all keys exist when app starts. Then here auth headers returns a headers to use for API calls. Read access token from a session state. If no token returns an empty dictionary, so authorization header. Otherwise, returns authorization bearer is a token. Moving to next line. Def API post. It's a path and JSON is none and header equal to none. Wrapper around a request.post. Then request.post is a API plus path. Calls a full URL, concatenating a base API to the path. Timeout prevents hanging forever. If an exception occurs, network can't connect. St.error means displays error function and returns none. The scholar checks this. Exactly, this is the same pattern for a get request. Here I want to share some note. This returns a request response object for or none on failure. Callers must check a request and status of the code. Then moving to next. Here is the login details. Nmk portal name, subheader, login UI is to build a Login AI builds the login screen. st.title and st header shows the heading and subheadings. With st form, login form creates a form so that fields submit together. Then email creates the inputs. Then it's submitted form. If submitted, if not, if user is submitted form, validate both fields are presented and shows the error and stop if not. If response is none, the API post wrapper already shows the connection error when shows friendly message and exists. If respect is none, the API post wrapper already shows that connection error. We shows that friendly message and exist. Token error. Token as JSON and get access token. Abstract token from JSON. This assumes that API returns an access token. This token missing shows error. On successful save success token and user email at the face session state and shows a successful message. Time sleeper. Slide pause not necessary but gives UI time and shows successful. Then st rerun forces Streamlit to rerun that script immediately. That switches you to the login UI ID. Then starting the exam header, all the headers and API file. If, if request or request status is code is 200 error is unable to start exam, please try again. Then it returns. A start exam triggers a backend and to create a start exam from the user. Then it calls API post exam start and headers. Expects backend to require auth headers and bearer token. If response is missing or status is not 200 and shows the error, then exam ID assumes response contains all question identifier like a ID ABC1234. Next, it calls a get exam. It features exam details question and list of time allowed. It is a parased data equal data JSON means it is a parased JSON with keys, questions, and time allowed in a seconds. This is the this line set of session state values with a exam data. Questions is expected to be a list of dictionaries. Each question dictionary should be a include in exam ID, text, and choices. Mm, Answers reset the empty. Last saved resets resets which answers were saved to backend. Time remaining from time allowed in seconds. Then status in progress indicates exam running. Last timer tick is shows the records a current time for a timer logic. st rerun immediately re-renders the app to the token user into a exam UI. Auto save answers. It's defined save answers exam ID, QID, and index. Tries to persist and single answer to the backend. These lines prepares a headers and calculates a time elapsed in seconds, timer used and so far. Payload structure that was called backend endpoint and accept to accept. Then post payload to exam ID and save answers. If backend returns 200, updated last saved and index returns true. Otherwise returns false. Answer save and return success. Failures so callers can show UI feedback like a thirst. Then here we are submitting the exam. Finalizing the exam. First it checks the if already submitted to avoid duplicates. Iterates here this line shows that iterates all questions, attempts to save any answer of present ensures everything saved before a final submit. Here this line shows the time elapsed. It means uh, exam login how much time it's used. Calculating the elapsed time and post the exam ID and submit with final time elapsed. If backend fails or returns 200, shows the error. Else, mark session state as a submitted and status is completed. Here next, exam UI. Exam UI renders the exam page. Immediately returns the if submitted is true, prevents reshowing a question UI after submitted. Splits a page into two columns and narrow a left for timer and summary and widely right for a questions. Converts remaining seconds into 2 minutes and a seconds. Then header of a right column shows the loop overall questions, one based index and shows the question one and question two, etc. From each question, get index ID, text and choices. Current answer index and index previously chosen as a default is 0. So radio shows the previously selection. Selected ST radio. Here renders are radio button group of these questions. Here key FQ and quit string means ensures each radio has that unique streamlit wide key and widest state of persist across the returns. Lab visibility collapsed hidden a label since the prompt is above. Then it converts a selected value of the text and back to its index in choices. This is a safer than assumes radio return index. If something odd happens, value not found. Default is 0. Compares newly selected index with a whatever stored in answers. If different, updated in memory. Session state for answers. Call save answer and persist backend. If they saved return access, shows a quick st toast. A short pop-up confirming save. Then st divider. If a question ID is recorded in a last saved, that's backend accepted it. Shows a small capital. Then answer saved. ST divider draws a horizontal line between questions. After listing all questions, it creates a center submits button in a middle of column. One click, call submit exam, then ST rerun to re-render. Submit exam will save a pending answers and call backend and submit endpoint. Then moving to timer logic. Inside an exam UI. This code blocks decreases a time remaining every second using st rerun. Then re-executes the script repeatedly. Then current time. If so, time is remaining is decrement by one. Updated last timer to tick and rerun. This timer sleep is zero point 0.1. Then a small pause. No strictly necessary. If time remaining reaches a zero, then show warning. Call submit exam. Then rerun. If less than 1 second has passed, it sleeps 0 point and reruns same UI response. Mm. Here, as we have to observe important behavior of Streamlit runs top button on each interaction. This loop will st rerun to emulate ticking timer. This approach commonly in Streamlit, but can chatly main reruns. This works, but bear mind can produce many server and calls rerunners. Here is the result UI. Request result data, then exam IDs for a backend exam and backend exam ID result. If okay, praise JSON into a result data. Display scores and different messages based on their threshold. Score score is score is greater than or equal to 70, so successful and balloons marks pass. Uh, if score is 50 less than 50 less than or equal to score and less than 70 shows good effort and warning. Otherwise, it shows a encouragement, study more. St dot subheader for question reviews. Will say sidebar showing user email and login button on logged out. Details all keys and st session state. It shows that here we title as Welcome Nmk Certification Portal. ST write test your knowledge. S2 and ST write ready to begin your certification exam. You have 30 minutes to complete your exam. ST info contains a answers automatically saved as you go. So don't worry if you need to take a break. Then start exam as a primary user container with this a true decides what to display. If submitted, if submitted status completed, then it shows a result. If status equal to in progress, shows the exam UI, then running time. Else shows a landing and start page with the explanation and sender start exam button and calls start exam. If name is main, standard Python boilerplate when runs a directly not imported call a main. Then I want to give a small summary on this app front-end file. App starts like int session, ensures session key exists. If user not logged in, your login UI shows the login form. On success, access token and stores UI reruns. Logged in landing page shows a start exam. Clicks it called start exam. Pictures questions and timer. Set status in progress. Exam UI renders all questions radios. Each section. Update ST session state means answer. Call save answer and persist backend to the auto save. Timer logic inside exam UI decrements a time remaining every second by using st rerun. When a time runs out, submit exam called. Submit button calls submit exam, which ensures all answers saved calls back and submit endpoints and set status to completer. Result UI fetches results and display score and question review option starts. Another exam resets session case, import implementation notes, and pitfalls to watch. Backend contract. This front-end assumes certain endpoints and JSON format. Post and login are access token. Post exam starts are exam IDs. To get exams, timer implementation used to repeated ST rerun and timer sleep. This works but may cause a lot of reruns in heavier apps. Considering using ST extreme experimental memo or more efficient mechanism on web stocks. Race condition. If multiple autosaves happen very quickly, this backend may handle concurrently and this last mechanism helps to avoid duplicate and saves that and clients runs. So that's all about this file. Finally, I will run the both files and I will show you the front and back end. First, we will activate your backend UVcon backend dot app dot main app reload. Here we get a link of the backend file. Follow the link. Your docs. This is our backend. Right? Then I will go for registration. Try it now. Give some example. Email kiran09@example.com. Your password is string. I will give like Kiran. Name same as a Kiran. Then execute. Execute. Here it's showing like email already existed. we have to same line. I will add like Eden Sai. Then go back. This is about a backend. Moving to next. Open new terminal for frontend. CD frontend Streamlit run app.py. Here is our front-end page. Title Nmk certification portal. Uh, Before we save that email like Kiran Sai 09 the rate of example. Password given in a string Kiran. Then login. Here is our front-end code. Welcome to Nmk certificate and test knowledge. Test your knowledge. Ready to begin certification exam. We have 30 minutes time and 9 questions covering various topics. Here it's showing that tip your answers are automatically saved as a go. So don't worry if we need to take a break. Start exam. Here counter timer countdown. How many questions we answered it shows. NMK portal user email. After answering, I saved one question. I will save randomly some answers. Then submit exam. The exam result shows keep learning. Your score is 40. As I answered that, randomly I answered wrong answers. Second answer I answered a tuple, but it's a dictionary. Then third question I answered of some, it's a length. I answered 9, but it's a 8. That's all about this. Thank you for listening. Thank you.